Good morning, students. Today we are going to be doing square roots and radicals. This is lesson 2.6. Okay, let's go right into a definition of what a square root is. So a square root is one of a number's two equal factors. One of a number's two equal factors. Okay, so we have talked about factors. Those are two numbers that when multiplied together make the number. So let's talk about what this means. Okay, first of all, a square root has this symbol. Okay, you can write that underneath it. It is not division sign. It is kind of like a check mark with a little line out in front of it. So if you had like the square root of 16, okay, we're going to take the two equal factors of 16. So what two numbers, what one number is the same number, makes 16 when multiplied. So that would be 4, right? 4 times 4 is 16. So I'm going to write it two different ways here. I'm going to write it like this first so that you see that 16 is 4 times 4 or 4 squared. So really you're looking for the square that makes this number. And then you're just writing out your answer. The square root of 16 is just 4. Okay, you take off the square root sign. Don't leave it square root of 4 because some people do that. And you are not writing 4 squared. Okay, it's not 4 squared. That's what's underneath here. 16 is equal to 4 times 4 or 4 squared. But the square root of 16 is equal to just 4. Okay, so let's go through a few examples. But first, remember this is a square root sign, and the number that's inside of that is called a radicand. I know, it's a weird word. I don't really use this word very often. I just say the number on a square root sign, but your book might say it to you in instructions or something, so I want to make sure that you know this is called a radicand. Okay, so let's do a few examples. Okay, example 1 is the square root of 25. Oh, and sometimes the square root has this little line and sometimes it doesn't, depending on the book, depending on who's writing it. Sometimes your calculator might look a little bit different. So if you see it without that little line, that's why. Okay, so I want you to do this on your own. You're trying to find two numbers that when multiplied together make 25. Okay, and then you're just gonna write that number one time. Okay, so hit pause, figure out what the answer is, and come back. Okay, so everybody should have figured this one out. You are still not allowed calculators at this point, so you kind of have to do this old school, or you can use multiplication charts. So 25 is the same as 5 squared, right? So your answer should have been 5. Okay, example 2. Example 2 is the square root of 36. Okay, so hit pause and answer that one. Okay, now that you're back, 36 is the same as 6 times 6 or 6 squared. So my answer is going to be 6. Okay, hopefully everybody's getting the hang of this one now. Okay, next one, example 3. Square root of 4. Okay, hit pause and work that one out. Okay, the answer is what times what is 4? 2 times 2. So your answer is 2. Okay, next one we're going to go a little bit different. These were all pretty simple. So now we're going to do example 4. Example 4 is the square root of, negative square root of 16. Okay, so if you have a negative out on the outside of the square root sign, then you're just going to ignore that for now. You're going to find out the square root of 16, which we already found out was 4, and then you're going to put the negative in front of it. Okay, so that one was pretty easy also, but notice that the negative sign was out in front of it, okay, not inside of it. We can't find square roots of negatives right now. You'll learn how to later in another class. But we can't take the square root of a negative because two numbers times each other are not going to give you a negative number, the same numbers. Okay, now we're going to move on to some different radicals. So see how this says radicals? Okay, radicals are the same thing as square roots, kind of, but we do them with a different number. So let's take, for instance, a cube root. So everybody write down cube root. So remember right here we had square roots. And when we had square roots, we were looking for the square of that number, right? Well, the cube root is the same thing, okay? It's actually the same thing as square root, except for you're looking for the cube of the number. So here it is one of a number's three equal factors. So now we're doing the same thing, but we're looking for a number, the same number that can be multiplied 3 times. Okay, so for example, if I have the cube root of 27, okay, so how do you see cube roots? The other one was just a square root sign, but a cube root looks the same except it has a little 3 in front of it. So this is telling you that I'm looking for something with 3 factors, the same 3 factors. Okay, so let's do example 5, okay, and we're going to do this one together. So we have the cube root of 27. So I'm looking for something that when multiplied 3 times together, not times 3, but 3 times together, will make 27. So I know that this is not even, so I'm not going to be looking for an even number like 2 or 4, okay? So I'm going to try 3 because 3 is a little bit lower, and when I start multiplying them, maybe I'll get to 27. So I'm going to check if 3 times 3 times 3 will equal 27. So don't just say, oh, this is close to it. Check it, okay? So if I do 3 times 3 is 9, and then 9 times 3 is 27. Okay, so that works. So 3 times 3 times 3 equals 27. So this number works. Now because it's the cube root, I'm just writing that number 1 time out here. Okay, so I have to, if you have a 3 there, it means you have to get that a number that multiplies 3 different of the same factor. Okay, so 3 times 3 times 3 is going to make the 27. Okay, let's try another example. Example 6. We have the cube root of -8. Okay, remember in this last one I told you that you couldn't have a negative inside? That's if it's a square root, or a 4th root, or a 6th root. It's even roots, because even numbers will not make a negative sign. So that's why I can't have it inside here. But down here I can have it inside, and I'm going to see if you can figure out why, and if not, then you'll come back and listen. So try to find 3 numbers, 3 of the same number, that equal -8. Okay, hit pause and go ahead and do that on your own. Okay, now that you're back, let's see if you figured it out. Okay, so 8 is a really small number. It's also even. So I'm going to go with 2 because I already know that 3's make 27, right? So I'm going to go with 2's and see if that will work. But this has to be a negative, so I'm going to try -2. Okay, so now I'm going to see if that's correct. So if I have -2 times -2, that's +4. And then a +4 times a -2 is a -8. So yes, this -2 times -2 times -2, or -2 cubed, right? This would be the same as 3 cubed. This right here is the same as -2 cubed. Okay, so I have cubes there. That's why we have the cube root. Okay, so since that is correct, all those -2's are equal to each other, then my answer is -2. Okay? Okay, now we have some, now if this was a 4, so this is a cube root, But we also have fourth roots, fifth roots. You can go up as high as possible. But the numbers start getting really high and unmanageable. So most of the time you're just doing squares and cube roots. On test, it will just be squares and cube roots. But on your homework, you might have a few of other ones. Okay, let's go on to example 7. Sorry, I have to take time to erase this board. Okay, example 7 is the fourth root of 625. Okay, now this is another high number, so I want to think about it. What numbers could I use to get up to 625? Well, that 5 at the end is going to help me, because if it ends in a 5, a lot of times it can be divided by 5, right? So let's try 5 here. So I need 4 of the 5. So I have 5 times 5 times 5 times 5. Okay, so now I'm going to try that. Well, I know 5 times 5 is 25, right? And 5 times 5 is 25. Okay, so now I have 25 times 25. Does that equal 625? Okay, yes, it does. I can go here and do scratch work, but I know what 25 times 25 is, and it's 625. Oops, I forgot to put the 4. Okay, so the fourth root of 625 is just 5. Okay, don't think, oh, that's small, and don't put 25. That was just us checking to make sure 5 times 5 times 5 times 5 is 625. The answer is just 5, because I have 4 of them, the factors, multiplied out. Okay, example 8 is a little bit harder. If you want to try to pause and do it on your own, you can. This is the fifth root of 1024. Okay, if you want to pause and try it, you can. If not, just stay with me. Okay, so we need 5 factors that make 1024. Okay, there's a 4 at the end, so my factors are probably going to be even, and I'm going to say maybe 2 or 4, okay? Don't always think that because it's a big number, it's not going to equal something big. Okay, I mean, have a smaller factor. Okay, well, if I did 2s, if I did 2 times 2 times 2 times 2 times 2, remember we're trying to do it 5 times, I'd get 4 times 4 times 2. Okay, that's not anywhere close, right? 4 times 4 is 16, times 2 is 32. So nowhere close to 24. Okay, so let's try the next even number, and let's try 4s. Okay, so that's going to give me 16 times 16 times 4. Okay, I know 16 times 4 is 64. So I'm going to do that first, so I don't have to do so much multiplication. I'm doing the stuff I can do in my head. So now I have 16 times 64. Well, that looks like I'm getting up there, right? So let's try it over here. I like to put my big number on top when I'm multiplying. Okay, that's 24, carry the 2. 36 plus 2 is 38. 1 times 4 is 4. 1 times 6 is 6. Okay, and then I'm going to add these all up. Oh, look there. We got 1024. So this is correct. 1024, the fifth root, okay, is the same as 4 times 4 times 4 times 4 times 4. You do not have to write this every time. I'm writing it for your notes so that you can visually see what we're doing. So now that I know that it's 5 of those 4s, okay, it's not 5 times 4. Don't think, oh, that's 20. It's 4 times 4 times 4 times 4 times 4. Okay, so now my fifth root is just 4. Okay? Okay, that was example 8. We only have, well, I was going to say one more, but nope, we don't. We have quite a few more. Okay, so because they want to get you through all the examples of what you will be seeing on your homework today. Okay, so example 9 is negative square root of 4 over 9. Okay, so now we're doing a fraction. So you might say, oh, this looks so much more difficult, but it's not. It's just kind of 2 square roots in 1. So you can also see this as, I'm going to put my negative out here, as the square root of 4 over the square root of 9. So they just use one square root so that they're not having to write it 2 times. But it's actually just finding the square root of 4 and then square root of 9. So we already know both of those. I think we did them in earlier problems. The negative stays out in front, and then the square root of 4 is 2, and the square root of 9 is 3. So my answer to the negative square root of 4 over 9 is negative 2/3. Okay, remember, you lose your square root sign once you write your answers. Do not leave those out there, or I will count it wrong. It's not even close to being right if you leave it like that. Okay, next one is find the cube root of negative 27 over 125. Okay, so we already found the cube root of 27. This is a negative out front, and because it's a cubed root, we know from our last example that it's going to stay negative. So we're going to have negative. We already found the square root of 27 in an earlier example. It was 3, right? Now for 125, I want to find the cube root. So what 3 number, or the same number when multiplied by itself 3 times, is 125. Well, once again, it ends in a 5, so I'm going to try 5 times 5 times 5. This is 25 times 5, and when I multiply those out, I do get 125. So 5 is correct, and my answer is negative 3/5. Okay, sorry, this was example 10. Okay, we have 15 examples to go, so I have 5 more examples. So let's see if we can get through these pretty quickly. Okay, example 11. Example 11 is a little bit different. It says write, okay, and I want you to write this all down, okay? Write the square root of 25 equals 5 using exponents. Okay, so make sure you write that down because you're going to have these exact instructions in your homework. So all they mean is kind of flip it on its side. We're going to lose the square root sign and we're going to change this to exponents. So if I lost this square root sign, so if I just had 25 equals 5 to the what power? That's what they're saying. Okay, I'm going to show it flipped around. So I'm going to have 5 equals 25. See, I lost that square root sign. But what exponent's going to go here? Squared, right? 5 squared equals 25. And that's my answer. Okay, one more like that. And this one you're going to do on your own. Example 12 is write 4 cubed equals 64 using radicals. Remember, radicals is the same thing as square roots or cube roots or fourth roots. Okay, so you're kind of going like this, going backwards. Remember, this is a cube. Okay, so write it like this, but with these numbers. Okay, hit pause and do it on your own. Okay, now that you're back, we're going to take 64 and put it under the radical sign. Okay, and we're going to have equals just 4. We're going to, this time we're dropping the exponents. So we added this square root. But this cannot be square root. This is not correct, right? We need to put right here this same number. So that's the cube root. And that's my answer. Okay, so up here where you have the square, this is a square root. In fact, if you put a little 2 there, it's not going to be wrong, okay? You could do that. It's just a shortcut not to have to. The 2 is just implied on this square root. So on here where you have a cube root or a cubed, you're going to change it to a cube root. Okay, that's example 12. Let's go on to example 13. 13, you probably could do this one without any help. Okay, but it does look a little bit different, so just want to make sure that you understand what they're wanting you to do. So example 13 is 8 times, if it's right next to a parentheses, a radical, anything like that, it's just times. If you don't see the sign, like the plus, the minus, all that, it's times. So I have 8 times the square root of 5 plus 4. Okay, so what do you think you do here first? If you think you know, you can hit pause and try this on your own. But what we're going to do is we treat this inside of this square root like it's a parentheses. We're going to add those two together. So I have 8 times the square root of 9. Okay, now this is not simplified all the way. I want to keep going. If you can keep going, then you always keep going. Okay, so the square root of 9 is 3. So I have 8 times 3. Okay, and I took away the square root sign because I already found the square root. And now I do 8 times 3 is 24. And that's my answer to this problem. So I actually worked it all the way out. Okay, example 14. Okay, I don't know. I think that example 14 and 15 are just reviews of what you've done before. So example 14 is 7 plus 11 over 3, right? Yeah, over 3. Okay, so this is just working a regular problem. So I have 7 plus 11. If you have, this can be considered a division in algebra. Most of the time that's what it is, or a fraction. So we're going to just treat it as kind of both. But whenever you have that line, you work everything, you kind of treat this like it's parentheses, okay? Because it's all on top. Okay, so you can't just do 7 divided by 3. You have to treat this as all one. So I'm going to add those together first. 7 plus 11 is 18. And then I have 18 over 3. So some people might see this as a fraction and say, oh, I'm finished because she told us to leave improper fractions. But it's actually not simplified all the way because it can reduce. 3 goes into 18 6 times. There's no leftovers, so the answer is just 6. Okay? You can also see this as not a fraction. You can see it as division. 18 divided by 3 is 6. Okay, and the last one is 2 times the absolute value of 5 minus 14. Okay, absolute value was a long time ago, right? A couple of weeks ago. So let's try to put on our reminders. Okay, so I have 2 times the absolute value of, now I have to do 5 minus 14. Remember, when you have minus, that means you're changing this to plus and negative. So now that I have 5 plus negative 14, that's a negative 9. And what does the absolute value signs tell you to do? That tells you the absolute value means that it's the positive, right? So I'm going to have 2 times positive 9, which is 18. Okay, so those last two were kind of reviews. Actually, this was example 15, sorry. So those last two were kind of reviews of what we have done before, just adding in a couple more steps. Okay, so that's your lesson for today. We are actually done with chapter 2 after this. We'll be doing a review and a test after this, and then we'll start into chapter 3. Okay?